She's the director of the Code Craft Group, where a team of researchers explores how computing technologies can extend and transform familiar and accessible materials, and how these integrations can broaden expressive and technical possibilities for designers. She received her PhD in Technology, Media, and Society from the University of Colorado at Boulder, and a master's degrees in Entertainment Technology from Carnegie Mellon University and Media Interaction Design from Iowa Women's University. You can find out more information about Dr. O and her group at codecraft.group. And I'm really excited to turn over the presentation to Dr. O.
Thank you, Christina. Let me share my screen. Do you guys see the title here? All right. Okay. Hi, everyone. For some reason, I cannot. Uh-oh. Let me try that. There we go. Now you see the title, right? All right. Hi. Thanks for joining the talk today. As Christina introduced, I'm HyunJoo Oh, and I'm a faculty at Georgia Tech, and I'm also leading CodeCraft research group. To give you some sense of who I am and what my group works on, we design and build technologies, including tools and methods that integrate familiar and accessible everyday craft materials with computing. And we work with a broad range of designers, from professional designers to K-12 students and educators. Our interest is in how computing technologies can expand current ways of using everyday materials and tools for designers. And so while developing technology, we look at how the combinations of familiar materials and tools with computing technologies can enhance the expressive and technical possibilities for designers. And we work on this because I think tools, materials, techniques that I would call all together as technology, I believe technology really shapes the way we think, make, and learn. So that's what I want to talk about today. I'll show you some of example projects and discuss how I approach creating technology for those who make things as a creative learning effort, and how technology can enable them perhaps to be more resilient in their creative exploration. So the first project example is paper mechatronics. Paper mechatronics is our term for an interdisciplinary design medium combining traditional paper crafting with mechanical, electrical, and computational components. And I worked on this project as a grad student for my PhD study. And with a whole group of researchers and advisors, I developed a series of design tools and fabrication techniques to invite others, in this context, mainly K-12 students, to encourage them, to enable them to develop their own paper mat models for creative design and engineering practices. And to support those learners, we developed a design simulator, which is still available in the web. So using the simulator in the web, people can choose what kind of motions and mechanisms they want to explore and design their model. Actually, I added just a video. So I'll just talk over with the video. So people can go to the simulator and then select where they want to start from, either motion or mechanism. And let's say they choose motion and go to open close. Then there they can modify local parameters such as linkage lengths, gear sizes, motor types. And under the same motion, they can also change the mechanism types. And then when they finish their design, they can go to parts and then download that as a PDF file. And using the file, they can cut and prepare the assembly parts. And then following the assembly instructions, they can build the working physical model. So we have developed 12 different movement modules. And in our workshops, students have adapted those into their own creations. So we have worked with many students and teachers, and you see here, how they have adapted into such creative and whimsical and beautiful stories and expressions. And all of these examples, for instance, are all based on a rack and pinion mechanism. And you can see how, just one mechanism can invite all sorts of, personalization space. And of course, almost always, there are some, extraordinary, creative individuals who want to go beyond what's given. And they often just, actively modify the given parts because those are made of, paper and cardboard, and then combine, multiple mechanisms to create their own structures. It's always really, fascinating. So from my stance as a technology designer, what I considered was, so when I started at the beginning, I developed it all from one dimension. Everything started from the mechanism dimensions. So the picture I had was people who choose, mechanisms they want to develop. But then while working with, groups of students, I learned that when they encounter unfamiliar vocabulary first, such as, rack and pinion gears, crank gears, I noticed that some of them just closed their mind. Noticeably many girls, they felt it's not their thing. But then about the exactly same activity, when we start with words of motions and frame the activity like, today we will explore a flapping motion, something that rotates. What are the things that move up and down? Then you see they really get excited and they just bring full of ideas. And then over the process, as students get engaged in the activity with their stories, they can gradually, explore the engineering terms and ideas step by step. And then the other consideration was leveraging the power of paper as a rich and empowering material, I would say. I say it's rich because paper invites the existing culture of paper crafting, aesthetics, and expressions. In the screen, you can see all sorts of drawings, coloring, cutting, folding. Those are just blended into the creative processes without telling them. And I would say it's also empowering because regardless of their actual skill set, even very young children feel like they can do something with paper. And, I think partly it's because paper is ubiquitous and, children are already familiar with paper and they feel like they can easily find more paper around. So I suppose that reduces their, fear of failure. And as a kind of related note, because of the reason, in any of these kind of, hands-on workshops, I always make sure that we prepare enough recycled paper, enough cardboard and cereal boxes for the workshops, because those materials can reduce their fear of failure. And I think that really makes a difference in their creative exploration. So whenever I share this work in academia, one of the most frequently asked questions is the assessment side. How we can study and assess, students' learning, what kinds of data to be collected, to be observed. And of course, we can, talk about in multiple dimensions. It could vary depending on, the research questions, collaborators, all sorts of, context makes difference. But here I want to share one compelling example. It's probably my favorite one. So this study was conducted at the DePaul University 2016. The workshop was in a partnership with Digital Youth Divas program. It was led by Dr. Nicole Pinkart. Now she's at Northwestern University, but 5 years ago, she was at DePaul and I was a PhD student, and she invited me to come to Chicago and lead the workshop. And that lasted 5 days from Monday to Friday, all day long. So it was quite intense, but I really appreciated that opportunity because that gave me a great chance to observe their progress. So for instance, when students were complete beginners, not familiar nor confident with their ideas and how things work, about the questions on what they are planning to make, students used vague words to describe their ideas because they are not confident yet and they don't know what's coming. And in the process of making, they easily change their ideas because in order to push the idea, they need to overcome certain technical challenges. So just to make things easier, they tend to change their ideas more quickly. But then from the day 4 and 5, I noticed that students started claiming their ideas and passionately share their planning by sketching, taking specific poses and gestures to describe specific motion they are envisioning. And the ideas can just go beyond the given movement module. And the thing is, once they enter that stage, they become positive on the challenges. They become quite resilient. They are willing to take on challenges with joy to reach a goal they set. So let me show you some of their work in progress presentation at the last day.
I actually want to make one figure a butterfly. And now it's like this, it would be like this. And now, but I want to go forward. But to do that, I would turn it forward to make it move. Wings would actually go forward instead of going up. So the way I would do that is to turn it and make it go up. I wanted my ballerina to make this motion and to do like a high kick to make its legs go up.
So you see, first, students describe quite sophisticated and advanced level of movement design. Second, they presented ideas related to their interests, especially the second girl. She was learning ballet at the time, and she was kind of a girl dancing around during the lunchtime, and she bragged how she is a good dancer. So that's what I want to highlight here, I guess. That was really exciting scene, and I still vividly remember. Designing technology for creative exploration, I try to engage a hands-on making experience that people can connect their own stories, their own passion. And so to do so, providing agency through materials and tools they are already familiar with, I think that could be one way we can approach. So this project was my previous work, and now I want to move on to my recent and ongoing project at Georgia Tech. The first project was also inspired by the paper mech because in paper mech project, we always use the motor to automate the mechanical movements and to teach programming. And then at some point, I noticed that how a motor generates the movement is somehow black boxed. Basically, it's not transparent. So some students asked the question about it, but I felt explaining it by word was not enough, was not clear. And it's in fact not just about the K-12 level, because even in my university class, because I teach an intro level of physical computing class using the SparkFun's Inventor's Kit as classroom material. Any sort of electronic parts, sensors and actuators, those are packaged, right? Those are pre-assembled. So the underlying electrical phenomena are invisible. So this issue inspired designing a kit, including mainly materials instead of parts, to lead students to start from exploring the electrical phenomena of sensors and actuators by creating their own parts and then adapt them into their creations. So that's what this new project is going to be about. We recently initiated a new project and named Unblackboxing Computing. It's in a collaboration with BSCS Science Learning Team, Sherry Shee and Colin Dixon. And in this project, we are investigating how we can use a set of raw materials that students can explore, just like craft materials and supplies. And here I also want to mention our approach of using materials instead of pre-made hardware parts. The approach is not new. We are inspired by prior work, primarily by Leah Buckley and her students. For instance, Hannah Purner-Wilson and Leah Buckley worked on handcrafted electronics. And especially Hannah has introduced such a huge body of DIY approaches to make parts from scratch using a variety of materials. And her work is just so fascinating. So if you're interested in this space, please check out her website. And Chi and Leah also have presented a pioneering work on paper electronics as well. They introduced how to use conductive pen, paint, and tape to create custom sensors in the context of paper crafting. So G has extended her work as commercial product. So check out Chibitronics website as well. So these work inspired our approach. And now back to ours, what we are adding now, what we are really focusing on is how we can extend this approach specifically for inclusive computing education. How this sort of material leveraged computing can make the working mechanism more transparent and broaden personalization space to bring students' own interest, narratives, and cultures, and how this can enable new kind of participation in computing. We are now preparing a series of studies with underrepresented middle school students in the Atlanta region for this summer. And our goal is to make computer science concepts and practices visible. So we want to make it visible in ways that encourage learning, agency, and feelings of competency and possibility. So please stay tuned for that. The second project I want to share is upcycling plastic bags. Again, this project was partially motivated from the Paper Mac one, because as said, I learned that using familiar, discarded, recycled materials can reduce students' fear of failure. So using recycled material was the first motivation of this project. And then the second motivation was the designers use a lot of materials for prototyping, especially through sheet-based fabrication in their studio practices. I don't know how much you guys are familiar with studio practices, but generally speaking, 3D printing kind of digital fabrication is getting more and more widely adopted. But at the same time, 2D sheet-based hands-on prototyping is very critical portion in design education in any sort of studio practices, because designers and design students build physical models as a way to facilitate ideation and explore form factors and identify problems through the models. So inevitably, this whole process consumes a quite amount of prototyping materials. So now in this project, we wanted to investigate ways to use discarded plastic bags as an attractive, meaningful, and practical, useful material resource for designers and their daily practices. So let me show you our work in progress project video. So as you can see, we are employing a heat fusion-based technique to make a new plastic sheet with intended thicknesses out of discarded plastic bags. And so we worked on developing a systemized design and fabrication process using widely available tools and techniques. And we created application examples to share, the exciting creative potential of upcycling plastic bags. All the presented, application examples are somehow intended to demonstrate different kinds of techniques, and we wanted to show, the whole diversity in a big picture. And then among all those application examples, for me, probably the most fabulous application example was this stool. So my student Himani made it by fusing 200 layers of plastic bags to make a very strong, robust sheet, and then assembled it. And I think it really shows, well, upcycling plastic bag is overall, it's kind of an area to discover so much more. I feel, with appropriate tools, methods, and a vision, we can surely grow this space of, using abandoned plastic bags as an attractive resource for designers. Otherwise, those are harm the world. Last year, because of the pandemic, we canceled our workshop. We initially planned it as a form of, user test, but then instead we conducted expert interviews with 3 professional industrial designers who have over 10 years of working experiences. And then in the interview, the experts appreciated enabling the process using multiple options of commonly available tools. and how the technology has transformed the thin and fragile material property of plastic bags into something very, strong. And also, I want to highlight it's maybe more than physical quality of the material, because using discarded plastic bags invite the broader context, including designers' creativity. Another expert stated the sustainability narrative impact. So I'll read what he said here. He mentioned, I like the notion that you start out with a raw material that already is saving the planet. And then he continued, the unique texture would add to the story as the material is cool, not virgin material, but recycled. It has a story to tell. And then he discussed how this kind of, reusing discarded materials can inspire, cool ideas for students. So given the huge possibility of this topic overall, I feel this project is in the very early stage. And I think more technology would clarify the vision further to be able to reuse plastic bags as a meaningful and useful resource for creative exploration. Now I want to move on to the last example project. This project was initiated during the transitional time between finishing my PhD at the University of Colorado Boulder and starting my current position at Georgia Tech. So with my colleague, Clement Sang, and advisors in Boulder, we explored how we can expand current scope of designers' paper prototyping by leveraging delicate cutting-based paper crafting techniques, which is also called as kirigami in Japanese. And we applied it into carbon-coated paper. In case you guys are not familiar with carbon-coated paper, you can find them in Amazon or any of craft stores. Those are electrically resistant materials, paper, and often used in K-12 physics classrooms as well. So throughout this study, we learned that there are two different types of carbon-coated papers. One on the top has carbon fibers throughout the entire composition, and the one at the bottom, it has only the top coated, the surface level. And as we connect those two different material composite with the voltage divider circuit, we can use them as sensors. And then we can also sense different behaviors because of those different material composite. The top one can sense the folding better, and the bottom one can sense the bending better. So now we apply those sensing behaviors to various cutting-based kirigami structures to explore creating aesthetically pleasing and computationally sensible tangible user interfaces. So let me show the project video as well. So we published this work in 2019, and we are continuing expanding it with grad students in my group. And we are trying to broaden the scope of materials, because applying those various cutting patterns to even rigid materials like plywood or chipboard, acrylic. We can also make those rigid materials flexible. And then, as much as I'm a big fan of, using paper for any sort of making, when you think about paper mag, I should also though say using rigid material is a crucial part of prototyping for designers, especially in studio practices. And in addition to that, nowadays, conductive materials like conductive spray or paint, those kind of conductive materials are made of carbon or nickel nanoparticles, and those products are becoming widely available in the consumer market and DIY community. So now applying those various conductive substrate into those cutting patterned wood and chipboard, we can make those traditional rigid material not only bendable, but also electrically sensible to read the level of bending behaviors. And we think this kind of combination could bring interesting, new, expressive, and technical possibilities to expand the space of tangible user interfaces. So recently we started co-design sessions with 9 graduate students, and it's still ongoing process. So we'll see, but please stay tuned for that as well. Now I want to step back and conclude this talk with what matters to me. I think my passion is in enabling designers to be more resilient and active in their creative exploration with agency, with more joy and excitement instead of fear. And I approach it by bridging familiar materials, tools, and practices that are widely accessible in their everyday lives. So as design technology, my group works on how our technology can enable designers to be able to flow adapting challenges as exciting adventures and engage them in their creative learning through making. I want to acknowledge all the presented work is done in a collaboration with such a great team effort within my group and with my fantastic colleagues. That's all I have prepared. Thank you everyone for listening.
Thank you for an amazing presentation. This was really, really cool. We've got a lot of comments in the chat thus far, just about how exciting this work is. So we can start taking questions.
Should I open the chat window?
I can start with Jai Hao. This design is incredible. What software is this? I'm not sure which software you're asking about, but also remember. Go ahead.
Yeah. So I noticed that the sensor project I'm really interested in. You are using that one. I assume you're using that one to testing the mechanic properties of different types of materials. So I noticed that when you are pressing that, this one. So so when you are pressing that material, so the on the screen it just simulates the movement of that specific material. So I want to know if that software is something you build it yourself or it's a third-party software. Yeah, because I want to use that in my project.
Oh, that's cool. That's cool to hear.
Yeah.
That software, by the way, is I suppose you saw the visualization of the sensing behavior. Are you familiar with Arduino?
Yes.
So when you open the serial monitor, you get the value as numbers, but then you can also go to some mode and then get the value as a graph. Okay. So we just hooked up our custom sensor and then kind of demonstrated it's working in this way. It's read by the circuit in this way. Yeah.
Okay, so you are putting multiple sensors on that material, right? You can catch different.
That's a good point. So it depends on
properties.
what kinds of bending behavior we design. So for instance, let me make an example. Unfortunately, I don't know where my mouse cursor is at this point. But like, where's my mouse cursor? Okay, there we go. Okay, this one. This one, you can see that we are reading either this side or the other side. So we didn't need to specify various motions. So depending on the application, motions we want to adapt for, I think those should be defined differently.
Okay. Yeah. Thank you.
So it's like a say if we make this, it would read any sort of bending, any of changes, and then if we want to read only this side of bending, the whole side of the bending, or one, then we can connect it all together just as one sensor. But if we want to apply, give some options, I want to read different motions of bending here, then although those are connected pieces, we can kind of divide, the hooking up the sensor part and then use them as two separated sensors. Does it make sense?
Yeah, makes sense. Yeah, got it. Thank you.
Thanks.
Okay. So George commented, many schools around the world need solutions like this. How do we think about selling this product at a high value? Many communities need resources and this product could help them.
Which one are we talking about? I think perhaps paper mag or somewhere here. Is it correct?
George, do you want to
Yes. I am not in the United States. I'm in Colombia. And right now we have a trouble because many communities do not have enough resources. And students in Colombia and maybe around the world doesn't have enough money to study. So I think the solutions like the share that you show us is very interesting.
Thank you. Thanks for saying that. Paper Mag project was initiated under National Science Foundation in the state. And so as a grad student, when I worked on the project, our focus was in, just working with, the whole context was in the state. And then around the time I started making the website, in fact, I made the website more as my personal portfolio. And then as I go out more as a user study form, having it available in the website made my life much easier because I didn't need to distribute all those source codes to their computers. So I just made it, in fact, for a very selfish reason at the beginning. And then as I, expanded my collaboration, I guess they kind of shared with someone they know and someone they know. And at some point I learned that quite some number of people started using paper Mag. So for instance, I often got, emails from Japan, Finland, saying really nice words in their institute. They are using it in their high school. They are using it. This is why, although the funding period is over, my portfolio, I'm keeping it as my portfolio. And it's my pleasure to kind of keep, making it kind of updated, although it's getting outdated now. But you see the point. I'm excited that some maker community are already using it, and within the scope of work that I can afford, when they often contact me just personally and ask some of the questions about how to navigate those resources, I try to respond that. At the same time, this is ongoing conversation, to be honest, with my team, that I'm not very confident and sure how long I can sustain this whole thing, but I would love to find a way. And this is why I'm so passionate. This is not about why. This is where I'm so passionate about. And this is why I love my job. So thanks for saying that. And this kind of question really inspires me to, continue making effort to make things, better and shareable with others.
All right, we have a question from Christian.
Yes, Professor, you in the abstract you mentioned that the main motivation for the study was to increase resilience and creativity. So, what drove you to think on those terms and when relating to the students? Were you seeing some sort of metrics or indicators that creativity was not enough, or academic advancements or achievement? What was the driver against that? Yeah.
Yeah, that's kind of thing. I always kind of roll my eyes. Where should I start from? But I really get excited about this discussion. I think, in a very high level, we talk a lot about STEM education and creativity and all sorts of the importance in modern language. But let me just use my just my language to share the essence of my belief, I would say. I think regardless of all sorts of domain differences that we say, things related to creativity, something related to creativity like art, music, computer science, and all sorts of, engineering. I think there are some common grounds across all of those, regardless of domain-specific differences. And I don't know how to describe it exactly, but I believe those should be somehow connected to something we consider as inventiveness, curiosity, wondering, exploration, that sort of things. And I want to, I think I chose to make my approach based on making. And what I started observing and noticing is that I wouldn't say everyone, but if this kind of approach meets their interest, they become very strong about challenges. Otherwise, they would give up. But once they get engaged in something, the creative processes of making, I think some students become very strong and advance their ideas. So that's what excites me, and that's my motivation. Does it answer to your question?
Yeah, thank you.
Thank you.
All right, I see Brandon's hand, and then we'll go back to some of the questions from the chat.
Hi, can you hear me? Yeah, okay. First of all, thank you very much for the talk. It was really cool.
Hi, Brandon.
So I study compliant robotics, or like soft robotics. We design the path planning of them. And so I find a lot of this compliant mechanics stuff really interesting. To what extent do you think your research could be used to maybe further like research into compliant mechanics through like, introducing like low cost like robots or something, or automated tools for maybe some economies where using these like low cost materials would be useful, or even just like introducing the notion of like a compliant robot or a compliant tool to like a more general populace.
Wow, that's a challenging question, I would say. I think, in fact, it's somehow the opposite for me. I bring a lot of motivation from those fields. Now, my lens, whenever I look around those fields, so much, recent advances from, like you just mentioned, compliance mechanics. That's one example, but there's just so much out there. Whenever I look around those fields, I think of how I can adapt some of those into this kind of learning through making. That's the term I would use. Maybe I should, in order to do so, maybe I should lower some of the performance they kind of made using the high, lab equipment, but using things that, we can use around us, we can still somehow mimic some of those effects. Things like the sensing kirigami, that's not like super accurate sensor. Things that I demonstrated here, all those 3 custom sensors, I wouldn't say those are really like as stable as, off-the-shelf parts. So the purpose would be a bit different. So now going back to your question, how this kind of work can potentially make a contribution. I'm not super confident, but if anyone in the field is interested in democratizing technology, what they have done could be somehow, adapted into broader context of applications. If they are interested in that, I think what we have done could be good references.
It's a great answer. Thank you very much.
Thank you.
All right, so to bounce back to the chat really quick, do you run any cost benefits analysis for any of these prototypes to see if they could be successful in the market as consumer goods? Great question.
That's a good question. I wish I can make money out of this. As you can see in this slide, actually, it's right here. This project was recently funded from NSF. And when we, bring funding like this, we kind of make promises in proposal, right? And some fundings are open for specifically for commercialization. But in this context, I think we claimed our goal as trying to lower the cost with part of that, because we work a lot with public school teachers, and so material cost is critical factor, and we try to use off-the-shelf parts, off-the-shelf materials that they can get when necessary. And what this also means is, at some point, for instance, after 3 years, if we want to really make it available in the market more as a kit kind of form, I would say why not, but I may need to find a good partnership to make it.
Okay, so Dimithu, I might be mispronouncing that.
Okay, it's okay. Thanks. Thanks for the talk. I have.
Hi, thank you.
I have a bachelor in mechanical engineering. I'm very curious about the mechanisms in your first project. So I'm wondering about what you can and what you can't implement as far as concerning the mechanism. For an example, is it possible to implement let me say quick return mechanism? I think you heard about that.
So
yep,
that's really exciting mechanism.
Yep.
We tested in the process, but I don't think it kind of has some of that effect. And okay, let me step back and say this from here. First of all, as said, at some point, as I decided to set my focus as making things more available and accessible and friendly for beginners, I somehow needed to make decisions to simplify the communication. So you may see that, for instance, since you're from mechanical side of mechanical domain, you see the crank mechanism.
Yep.
How it supports the movement is not straightforward up and down, if we say that, right?
Yep.
It's kind of the swing motion, in fact. But I rather made it under up and down because I noticed that when people adapt this motion to their creations, this kind of, instead of making as another variation, I thought, starting from the simple idea, go up and down. Oh, by the way, this up and down is a little bit different kinds of motion. I try to encourage them then gradually specify what they see. So what you mentioned, quick return kind of motions and all of those terminologies and the concepts, how each mechanism support what kind of motion each of those specifically afford. I would say the simulation name is Fault Mecha. This Fault Mecha supports very simplified version of mechanical design. And the reason is because this tool is designed for beginners.
Okay, that's okay. Thanks.
Thank you.
All right, we might have time for one more question. I'm gonna go to the chat and see if I can find.
Wow, you guys have very vibrant
This is
Q&A.
the
I
most
love that.
questions I've ever seen in our yeah.
I'm impressed.
Let's see. I think I like this one, so I'm selfishly picking them all. Are there any of data visualization analysis in the Karigami design, data visualization students and the team?
I wish we have. Are you interested in that? We don't. Yeah, because my mouse is not working, I'll just go this way. So in this work, part of the tool package we are working on includes modeling side of it. Are you familiar with Grasshopper? It's kind of the plugin within Rhino. So we use the Grasshopper as something people can as a parametric design tool. We thought of kind of just like a FoldMaker kind of a way simplified web simulation tool, but it didn't go well. So we kind of chose to use what's already widely being used. But to be honest, I wouldn't count it as an advanced visualization tool. It supports modeling.
Well, thank you so much for such an interesting and engaging presentation and such really cool design work. Do you have a slide that has your contact information just in the event that students, because I think you might have some folks interested in learning more from you or even potentially, finding ways to work with you. So Dr. O's contact information is on the screen here, email address, and please check out the CodeCraft group. And thank you everyone for attending today. Have a great weekend.
Thank you, Christina, and thank you everyone. It was really, really fun time. Bye-bye. Thank you.